And welcome to the Ray W. Herrick Labs. I wish we could do this in person tonight, but this is a good way for allow many of you a chance to experience what happens here in West Lafayette. I just wanted to start tonight before we hand off to some students for a quick overview with a little bit of history about the labs and what we do. So I'm standing here next to an artist rendition of our original building, which we still use today. So I'm in a newer facility that was built in 2013. Herrick Labs was founded in the 1950s and was the original interdisciplinary lab on campus. Historically, we had a strength in heating, ventilation, air conditioning, and refrigeration. And the lab started as a collaboration between animal science and mechanical engineering. Even though the original building and the weather vane on top still stands, and we still use that for research, we've come a long way since trying to cool down animals. Today, we're the foremost laboratory in the world doing HVACR research. And our work in that area has led to us becoming really preeminent in a number of other areas as well. Today, if you were here, and as you'll see through the virtual tour this evening, we have kind of world-setting paces in research in areas ranging from noise control, vibration, energetic materials and advanced material systems, powertrain systems such like you'd find in the next generation of automobiles. We continue to do things in smart buildings, and you'll see our living laboratories tonight. And we're also on the cutting edge of doing work at the intersection of psychology and engineering with our perception-based engineering laboratory. And those are just a few of the areas that we're really proud of that we support here in the laboratories. As director, my role is to make sure that students like yourselves have the opportunity to come join us here in West Lafayette and conduct research which is meaningful to society. That's something we really pride ourselves in the lab, is doing research which is relevant. Things that came out of this lab include products that now make over $1 billion a year, keeping people cool, safe. Products that have changed lives of people through safer understanding of buildings, even in the presence of horrible pandemics like COVID. We've helped governments solve problems associated with energy, environmental protection. We span the gamut in terms of application spaces. And I think tonight, as the students give you a tour of some of the exciting things they're doing, you're going to really enjoy what you see. So with that, let us kick it over to the video, and welcome to Herrick Labs.
Hello, my name is Andrew Hagan. I'm a master's student here at Herrick. I'm in my second year, and I'm going to show you some of the research that we do in our high bay facility. So first of all, I'm going to flip my camera around and show you the space. So this is a full 2-story high bay area. We have a couple of different pieces of equipment and research that we do in here. So first of all, I'm just going to show you this quickly. This is a PCB mill that we use to make custom PCBs and parts. So here's a small example of that. We also have in this space, we do a lot of either large-scale experiments or vibration-related experiments. So this is a shaker that we use to do low-frequency excitation of materials. So this is a really large scale piece of equipment, and that sort of fits into what we do here in the high bay. I'm going to flip around now and show you, this is my own research project. This is a standing wave tube, which is used to find the acoustic material properties of, a very small sample of material that would actually fit right in here in the tube. So this is what my research centers on. That's a printed circuit board with microphones on it and electronics to run it. So now I'm going to flip you over to Zachary Siefer, who's a PhD student in our group, and he'll show you some of the other research that we do here in the high bay facility.
Hi, thanks, Andrew. Like you said, I'm Zach. I'm a third-year PhD student here in the labs. I'll show you the rest of the high bay. Around. We won't nearly get to see everything in the labs today, but show what we can. So here is a custom inkjet printing system. And then behind it, a drop shape analyzer, the spaceship looking thing that we use to analyze some of the inks for inkjet. And here are just a few of the samples of some things that we can do with that, some of the capabilities. So we have a silver printed bridge wire, some nanothermite and the Purdue P that's there, as well as a spark gap. So a variety of different types of research that can be done with that. And part of it also for functionalizing sensor boards, which is over on this half of the high bay. So if you can imagine with Herrick's area of expertise in high performance buildings and vibrations, we develop a lot with gas sensors, and that's what most of this space is here to use. So we have the fume hood here where we have a sensor test going right now for a formaldehyde sensor. And then all of the instrumentation over on this side, including mass flow controllers and then gas bottles on the other side to help control the experiment. And all of that really boils down to one of these two prototypes that we have. So on the right is a chemi-resistive type of sensor prototype, and then on the left are resonant mass sensors. So there's 16 different sensors all on that tiny little board. There's my hand for scale. And so taking advantage of the vibration side of Herrick's expertise. So I guess with that, and then a big shot of the high bay to end with, I'll pass it on to Leon to go over the thermal systems side.
Well, thank you very much for joining in. I'd like to shift gears topic-wise and show you the thermal systems area. I'm myself a PhD student here and just finishing my third year, and myself work in HVAC and R. This is one of the wings that really houses a lot of the thermal systems that we work on. Here you can see an organic Rankine cycle. It's a neat technology to utilize waste heat at low temperatures. But I guess our bigger focus is really the refrigeration and air conditioning side. So here, for example, is a novel cooling cycle that basically reverses the fuel cell and generates a cooling cycle from that. This is a traditional vapor compression cycle, similar to what you have in your refrigerator at home, just that this one can be inclined and tilted dynamically, which we use to understand the effect of gravity better on such a cycle. Ultimately, this prepares parabolic flights, which should also enable these cycles to work on spacecraft in microgravity. Here you see now one of our psychrometric chambers. We have numerous of these large rooms where we can control the environmental conditions. We can set a range of temperatures from -20 Fahrenheit all the way to 120 Fahrenheit and test, for example, HVAC equipment. Here you see a set of compressor test stands to experimentally validate performances, develop compressors. This is a test stand that is about to, or it's helping developing a new ASHRAE standard for pipe sizing, which should ensure that the oil retention is in acceptable limits. I'm now at the northern end of the building, where we house a lot of engines research. We are for a moment away from the HVAC in our world. Just would like to showcase for a split second this really large truck engine. And the research group is working on hydraulically controlling, taking basically cylinders on and offline for a better operation. The research group is also involved in platooning of large trucks on highways. And now switching back to the HVAC in our world, here we have yet more small experimental test stands, but also another set of psychrometric chambers. Here's, for example, a test stand that you saw in the introduction video. It is refrigeration entirely on CO2 as a natural and environmentally friendly refrigerant. With that, I will hand it off and let you see the living lab.
Hi everyone, back up here now in the living labs. I'll give you a snapshot across the room. So as you can see, it's an office space for students, and there are 4 identical offices. You can see a snapshot over into the next 2 through this window. But these are instrumented such that we can use them for experimentation as well. So for example, like the gas sensors that I was showing off downstairs in the high bay would be something that we could test live in a space like this. Currently, the 4 of these spaces are instrumented with thousands of sensors. And as well, it's designed in such a way that it's interchangeable. So for example, it's almost like a mini psychrometric chamber, and that we can adjust temperature and humidity in the space in order to study both human comfort and as well just the new technologies that are being implemented in the system. And as well, we can apply thermal comfort from both the ceilings, the floors, and the walls, and radiative or your typical ductwork. And it allows us to have a lot of live experiments running to see how different things will react in a real world environment. That's pretty much it up here. So I guess with that, I'll pass it over to Andrew, who I believe is over in the East Wing of Old Herrick.
Yes, I am. So this is Andrew, back again. So now I'm going to show you a little bit of the old Herrick building. So this is that original Herrick building that Dr. Rhodes mentioned with the weather vane on the top that he showed you the visualization of. So I'm in the East Wing right now, which has a couple of different research areas housed in it, and I'll flip around and show you a little bit of that right now. So this area has, there's also some HVAC work in this area. You can see a little bit more of the duct work here. This area is kind of in transition. It's being repurposed for some new research. I believe that this is going to be used for a simulated Mars habitat in the future. And then over here is where we do some vibrations work. So this is a room where we do some vibrations work with energetic hazardous materials. And for that reason, we need to be able to completely seal it off and conduct the experiments remotely. So when work is being done in here, the students are actually seated outside, operating it 100% remotely, and they don't enter the space. So in this space, we have some 3D printing research going on here. You can see a couple of the printers. This is a tensile tester which we can use for compression and tensile tests of different materials. Over here, you can't really see it, but this is another vibration tester like the one that we saw in the high bay. This is a much smaller one that's used for higher frequency work. And it's set up with a laser Doppler vibrometer, which allows you to actually directly measure the displacement of the surface as the vibrational experiment is going on, and also a thermal camera, so you can see heat generation within the sample as it's being tested. I'll just walk over in here. This is another vibration tester. So this is what's covered up by all of the other apparatus over in that other room. And this is just basically the baby version of that huge shaker that you saw over in high bay.
2, 1.
So that's just some of the stuff that we have over in this east wing of the Herrick Labs old building. And now I'm going to pass it over to Daniel, who is in the acoustics wing, and he should be able to show you a little bit of that space.
Well, hello guys. My name is Daniel Soto Martinez. I'm currently in my second year of PhD here at Purdue. Currently, I'm inside the anechoic chamber, so you're not gonna hear, except my voice, you're not gonna hear any echoes or wind noise from the air conditioning ducts. So, just to flip it, currently we have different setups inside the anechoic chamber. There's an automotive transmission there. It's to see sound radiation from the equipment when it's running. We have also sound field projection equipment. We put an array of speakers, project sound, measure it, and see the pressure profile at a certain distance from the speakers to try and measure different combinations and see how we can recreate different pressure fields with sound. Going outside the anechoic chamber, you start to see have different equipment. One of the principal areas of study here in the acoustics wing is the standing wave tube. So this standing wave tube, what it does, it's to characterize different acoustic materials. So mostly foams, insulator material. It's used for common materials, but it's also used for Tinsulate. Tinsulate is made by 3M, and it's originally made as a thermal isolation material. Well, it was discovered that it also works well as an acoustic isolation material. So it's pivoted in a huge new industry with a different purpose. Going out, continuing in the acoustic wing, we also have the reverberation room. Now you're gonna hear a little bit more echo. So this is the completely opposite of the anechoic chamber. So here, instead of suppressing all of the echoes, we want to keep all of the echoes. And this is also used for characterizing different materials, sources. It's also used to characterize sources, so sound sources, to see how they radiate sound inside a room, inside a chamber, how they affect the sound without changing the volume or the air pressure around them. And we also have a couple of small sort of offices that are portable, smaller anechoic chambers. These are used for more small scale experiments so that we don't use the anechoic chamber. So I think that's it. There's also, well, if we can walk there, there's also an anechoic chamber, semi-anechoic chamber that works with heavy duty equipment, testing tires, paved surfaces and everything. So let me just quickly open here. And as you can see, there's a lot of equipment, big heavy duty equipment, and this pumps out a lot of sound. So that's why, in part, why we have the isolation, the acoustic insulation. But it's also to run experiments and see how mainly tires or heavy duty equipment radiate sound into the air. So with that, guys, I take you back to Jeff.
I know a question that probably many of you are asking or wondering tonight is, are there funded research positions available in Herrick? And I dare say that this year there could easily be 30 or 40 research positions available that are fully funded here for both master's students and PhDs. I know a number of folks are hiring. Certainly I'm hiring personally as well. And if anything you saw tonight sparked your interest, feel free to reach out to me or some of the people I mentioned, and I'd be happy to make connections for you. And before we sign off, I saw one last question come in, and it says, do you reply to the emails you get from students inquiring about positions? I think the key thing to keep in mind here is persistence is everything. I do try to respond to many of them, but I have to be honest with you. This may surprise some of you, but I receive up to 200 emails a day from students wanting to work in my own research group or in the labs. And so it's sometimes a challenge to get to all of them. So I try to make a point to hammer away at some of them every day. And I apologize if you reached out and I haven't got back to you yet, but I certainly do go through all those at least at a pace I can. And I think that's certainly true for my colleagues as well.